Filling the grounding socket of a 3-prong receptacle to create a 2-prong ungrounded receptacle is strongly advised against. The grounding socket in a 3-prong receptacle is essential for protecting against electrical shocks. It provides a pathway for excess current to flow back to the grounding system, preventing it from passing through the human body. By filling the grounding socket, protection is removed and the risk of electric shock increases. In many jurisdictions, it is against code to alter the grounding configuration of a receptacle. Filling the grounding socket would violate electrical safety codes and could result in fines or other penalties. Some appliances and electronics require a grounded connection to operate properly. Filling the grounding socket may prevent these devices from functioning correctly or damage them. In certain situations, a missing ground connection can cause excessive current to flow through the circuit, leading to overheating and potential fire hazards. In the event of an electrical accident or fire caused by an ungrounded receptacle, insurance companies may deny coverage if the alteration was not permitted by code. Instead of filling the grounding socket, here are a few alternatives. Firstly, using a 3-prong plug adapter for 2-prong devices. These adapters provide a temporary solution to connect 2-prong devices to 3-prong receptacles. Secondly, upgrading the wiring and receptacles. If possible, have a qualified electrician upgrade the wiring and receptacles to meet current electrical codes and provide proper grounding. Thirdly, using a ground fault circuit interrupter outlet. A ground fault circuit interrupter outlet provides additional protection against electrical shocks, even if the outlet is not grounded. Electrical safety is paramount. Never attempt to modify electrical wiring or equipment without proper training and authorization. Always consult with a qualified electrician for any electrical work. Grounding is a critical safety feature in electrical systems. It provides a low resistance path for fault current to flow back to the source, causing the circuit breaker to trip and to energize the circuit. This prevents dangerous voltage from appearing on metal parts of appliances or equipment, which could cause an electric shock. The grounding system typically consists of a grounding electrode, such as a ground rod or metal water pipe, connected to the electrical panel. From the panel, a grounding conductor runs to each outlet and appliance. This conductor is connected to the grounding pin on the receptacle, which is the round hole. When an appliance with a 3-prong plug is connected to a grounded receptacle, the metal chassis of the appliance is connected to the grounding system. If a fault occurs and the hot wire comes into contact with the chassis, the fault current will flow through the grounding conductor back to the source, tripping the circuit breaker. Without a proper grounding system, the fault current could flow through a person who touches the appliance, resulting in a severe or fatal electric shock. There are several common grounding problems that can compromise electrical safety. One problem is a missing or disconnected grounding conductor. This can occur if the wiring is old or has been damaged, or if the grounding conductor was not properly connected during installation. Another problem is a high-resistance ground connection. This can occur if the grounding electrode is corroded or if the connections are loose. High-resistance ground connection will not provide a low-resistance path for fault current, which can increase the risk of electric shock. Another common problem is using the neutral conductor as a ground. This is an outdated practice that is no longer permitted by electrical codes. When the neutral conductor is used as a ground, it can create a shock hazard if the neutral conductor becomes disconnected. If the grounding socket of a 3-prong receptacle is filled in, it defeats the purpose of the grounding system. The appliance will no longer be grounded, and the risk of electric shock will increase. It is important to note that using a 2-prong adapter to connect a 3-prong appliance to a 2-prong receptacle does not provide a proper ground. These adapters typically have a metal tab that is intended to be screwed into the outlet cover plate. However, this does not provide a reliable ground connection, as the outlet cover plate may not be properly grounded. If the wiring and receptacles are not grounded, it is recommended to have a qualified electrician upgrade the wiring and receptacles to meet current electrical codes. This will provide a proper grounding system and protect against electric shock. Another option is to install ground fault circuit interrupter outlets. A ground fault circuit interrupter outlet is a device that monitors the current flowing through the hot and neutral conductors. If there is a difference in current, It indicates that current is leaking to ground, which could be a sign of an electrical fault. The ground fault circuit interrupter outlet will trip and de-energize the circuit, protecting against electric shock. Ground fault circuit interrupter outlets are particularly useful in areas where there is a high risk of electric shock, such as bathrooms and kitchens. Ground fault circuit interrupter outlets can also be used to protect ungrounded circuits. While they do not provide a true ground, they can provide additional protection against electric shock. It is important to test ground fault circuit interrupter outlets regularly to ensure that they are functioning properly. There is a test button on the outlet that can be pressed to simulate a ground fault. The outlet should trip and de-energize the circuit. If it does not, the outlet should be replaced. Electrical codes require that all new construction and renovations comply with current grounding requirements. This includes the installation of grounded wiring and receptacles. It is important to consult with a qualified electrician to ensure that the electrical system meets all applicable codes and standards. When working with electricity, it is important to take precautions to protect against electric shock. Always turn off the power before working on any electrical wiring or equipment. Use insulated tools and wear rubber gloves and shoes. Never work on electrical wiring or equipment when wet. If unsure about how to perform an electrical task, consult with a qualified electrician. Electrical safety is not something to take lightly. The consequences of an electric shock can be severe or even fatal. By following proper safety procedures and consulting with qualified professionals can ensure that the electrical system is safe and reliable. The National Electrical Code, also known as NEC, provides comprehensive guidelines for electrical installations. It is updated every 3 years to reflect changes in technology and safety standards. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. The NEC is not a law, but it is widely adopted by state and local jurisdictions. Many jurisdictions require that electrical installations comply with the NEC. The NEC is an important resource for electricians, contractors, and anyone else involved in electrical work. It provides the information to ensure that electrical installations are safe and compliant with applicable codes and standards. Article 250 of the NEC covers grounding and bonding. This article provides detailed requirements for grounding electrodes, grounding conductors, and bonding methods. Article 250.4 provides general requirements for grounding and bonding. It states that grounding and bonding shall be installed in a manner that creates a low impedance path for fault current to flow back to the source. This is essential for protecting against electric shock and preventing equipment damage. Article 250.50 covers grounding electrode systems. This section specifies the types of grounding electrodes that are permitted, such as ground rods, metal water pipes, and concrete encased electrodes. Article 250.52 covers grounding electrodes. This section provides detailed requirements for the installation of grounding electrodes. Article 250.66 covers grounding electrode conductor sizing. This section specifies the minimum size of the grounding electrode conductor, which is the conductor that connects the grounding electrode to the electrical panel. The size of the grounding electrode conductor depends on the size of the service entrance conductors. Article 250.92 covers bonding jumpers. This section specifies the requirements for bonding jumpers, which are used to connect metal parts of equipment together to create a low impedance path for fault current. Bonding jumpers are required for metal enclosures, metal raceways, and other metal parts of equipment. Article 250.104 covers bonding of metal water piping. This section requires that metal water piping systems be bonded to the electrical system to prevent the risk of electric shock. Metal water piping can become energized if there is a fault in the electrical system. Bonding the water piping to the electrical system provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker. Article 310.15 covers ampacity of conductors. This section provides tables that specify the allowable ampacity of conductors based on their size, insulation type, and ambient temperature. The ampacity of a conductor is the maximum amount of current that it can carry safely without overheating. It is important to select conductors with the appropriate ampacity for the load that they will be serving. Article 406.4 covers receptacles. This section provides requirements for the installation of receptacles, including grounding requirements. Receptacles must be grounded in accordance with the requirements of Article 250. Article 547.9 covers grounding and bonding in agricultural buildings. This section provides additional requirements for grounding and bonding in agricultural buildings such as barns and poultry houses. Agricultural buildings are often exposed to corrosive environments which can compromise the integrity of the grounding system. It is important to use corrosion-resistant materials and to inspect the grounding system regularly. Grounding and bonding are essential for electrical safety. By following the requirements of the National Electrical Code and consulting with qualified professionals, one can ensure that the electrical system is safe and reliable. Always remember to prioritize safety when working with electricity and to consult with a qualified electrician if there are any concerns. The information provided is for general guidance only and should not be considered a substitute for professional advice. It is important to consult with a qualified electrician to ensure that any electrical work is performed safely and in accordance with applicable codes and standards. The National Electrical Code is a complex document, and it is important to understand the requirements before performing any electrical work. The consequences of improper electrical work can be severe, including electric shock, fire, and equipment damage. Do not attempt to modify electrical wiring or equipment without proper training and authorization. Always consult with a qualified electrician for any electrical work. The use of arc fault circuit interrupters is also very important. Arc fault circuit interrupters are designed to protect against fires caused by arcing faults. An arcing fault is a dangerous electrical condition that can occur when damaged or deteriorated wiring creates an unintended electrical path. Arc fault circuit interrupters can detect these arcing faults and trip the circuit breaker, preventing a fire. Arc fault circuit interrupters are required in many areas of the home, including bedrooms, living rooms, and dining rooms. It is important to install arc fault circuit interrupters in accordance with the requirements of the National Electrical Code. Surge protection is another important aspect of electrical safety. Surge protection devices are designed to protect electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protection devices can divert the excess voltage away from the equipment, preventing damage. Surge protection devices are available in a variety of types, including whole-house surge protectors and plug-in surge protectors. Whole-house surge protectors are installed at the electrical panel and protect all of the equipment in the home. Plug-in surge protectors are plugged into individual outlets and protect the equipment that is plugged into them. It is important to select surge protection devices that are appropriate for the equipment that they will be protecting. Regular electrical inspections are also important for maintaining electrical safety. Electrical inspections can identify potential problems before they become serious hazards. Electrical inspections should be performed by a qualified electrician. The electrician will inspect the wiring, grounding system, overcurrent protection devices, and other components of the electrical system. The electrician will also provide a report of any findings and recommendations for repairs or upgrades. It is important to address any issues identified during an electrical inspection promptly to prevent potential hazards. When selecting an electrician, it is important to choose a qualified and experienced professional. Ask for references and check the electrician's credentials. Make sure that the electrician is licensed and insured. Get a written estimate before work begins and make sure that the estimate includes all of the costs involved. Do not be afraid to ask questions and make sure that you understand the work that will be performed. Electrical safety is a shared responsibility. By taking precautions and consulting with qualified professionals, everyone can ensure that electrical systems are safe and reliable.